Hello, hello, hello. Good afternoon, good day, everyone. And, welcome to another episode of Japi. This is part 2 of our part 2 of our part 2 of our part 2. No, this is the kinematics part of our part 2 of physics. Okay? So, I hope you guys are excited. We're just gonna go right away in solving. Let me just, we're recording. I know we're recording. Alright. Let's just continue. Hope you guys are excited. This is literally just after solving statics. I just went with kinematics. So this is part 2. Hope you guys are excited. Let's proceed. Go 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 go. Hey, what's this? Sakuragi. Oh, I like Sakuragi. Ay, Sakuragi. Sakuragi, the basketball genius. Okay. What? Actually, it's written there. Sakuragi, the basketball genius, is to make a shot in a basket with 100 gram. Okay, we have a 100 gram ball at an angle of projection of 50 degrees. Okay. He is throwing at a height of 2.2 meters. If the basket is 3.2 meters tall, 3.2 meters tall and 11 meters far, that's pretty far. What will be the velocity he needs to throw the ball and the time of flight? Okay? Okay, let's do this. Okay, time of flight and velocity. Okay? We have 3 problems. I'm gonna do the shortcut method. Okay, you guys at home, you guys could do the long method by solving it by a component method. Okay, by a component of Vx is V cosine theta or cosine 50. Vy is equal to V sine 50. Okay? You guys at home, you guys could try that, but I'm gonna do the shortcut method. Y is equal to x tangent theta x tano. Yeah, my mnemonics is to remember this. X tano gx squared because you know why? Because I don't know. It's just because. Right? Right? That's my X tano because. Yeah. Anyways, that's how I remember it. If you guys have a better mnemonics or a better, what you call that, song or word for you to remember this equation, why not? So why? Because at the angle of projection, okay, in order to use this equation, the projectile motion, you have to make your angle of projection or the point of projection 0, 0. Okay, or this will be the origin. This will be the origin. So we are to find the velocity it needs to be projectile if it is to reach 1 meter for y, because the difference between that is 1 meter, 3.2 meter, 2.2 meter, and x is 11 meter tangent 50 minus 9.81 meter per second squared, 11 squared over 2 v squared cosine 50 squared. Right? That's it. That's it. I'm gonna move this to the right. Then move this to the right. So 9.81. I'm gonna simplify it. 9.81 times 11 times 11 divided by 2 divided by cosine 50 squared. 1436.4463 over v squared. Okay, is equal to 11. Simplify 11 tangent 50 minus 1. 12.1093. 12.1093. So V is equal to the square root of 1436.4463 divided by 12.1093, which is divided by 12.1093 square root He needs to throw it at 10.89. 10.89. Oh, you guys didn't see anything. 14 meters. Okay. Double check. How about let's just do this. Okay. 1 is equal to 11 tangent 50 minus 9.81 times 11 squared divided by 2 times x squared, that's the unknown value, times cosine 50 squared. Oh, syntax error, shift solve. 10.8914. Okay, that's the answer. Okay, velocity is 10.8914. See? Very fast. Okay, that's it. Right? And, you know, Vxt is equal to S. And if the range is to be 11 meter, if the range is to be 11 meter, 11 meter is equal to time times Vx, which is 10.8914 cosine 50. The time of flight is 11 divided by 10.8914 divided by cosine 50, 1.5712 seconds. That's the time of flight. Okay? Sakuragi, you're one awesome basketball player to shoot a ball 10.89 meter per second. Okay? Always remember your unit. Sir Japi, wrong. No, you have the wrong unit for velocity. Meters per second. Second for time of flight. Okay? Let's proceed to number 2. Number 2. Okay. What is number 2? The motion of a particle is given by the equation S is equal to 2t to the 4th minus 16t cubed plus 2t squared. Right. Where S is in meter, t in seconds, compute the values of velocity and A when t is equal to 0. T is equal to 2 seconds. T is equal to 2 seconds. Oh, we can do this, right? We can do this. In order to get velocity, we just differentiate it with respect to time, just like we do on the, on the problem solving on statics. If you guys haven't watched statics part 2, you should watch the previous video. Differentiate s with respect to time or velocity. So this will become 8t cubed. This will become 48t squared plus, what's that? 4t, And velocity will be 8 times 2 minus 48 times 2 squared cube plus 4 times 2. Okay, 16t cube. I think that's correct, right? So 2 times 2 is 4 times 2 is 8. 8 times 8 is 64. Right? 2 times 2 is 4. 4 times 48, 32, 160, negative 192. Right? 4 times 2 is 8. Okay? So the velocity must be going to the left. 72 minus 192 is negative 120 meters per second. Okay, that's the velocity going to the left at 2 seconds. Okay. Next, how about acceleration? Differentiate again, dv over dt is acceleration, and differentiate b is 8 times 3 is 24 t squared minus 48 times 2 is 96t plus 4. Substituting t to get the acceleration at 2 seconds, is equal to 24, 2 squared minus 96 times 2 plus 4. Acceleration is 2 squared is 4. 4 times 24 is 80, 96 minus 96 times 2 plus 4. This will become negative 92 meter per second squared. And that is the acceleration at 2 seconds. Okay. Okay, when it comes, okay, here's the thing, okay. Normally, what we use on the projectile motion, on the normal equation, is linear. Okay, normally, the most common motion that is taught, especially in high school and in college, is linear, uniform circular motion. First degree. Okay? But if we're given a third degree or fourth degree, we just have to differentiate it. The first differentiation of distance will be velocity, and the first differentiation of velocity will be acceleration. Okay? That's it. I think I did my differentiation correct. Why? Okay, I paused a little. I took some water. I drank. Let's continue to question number 3. The last problem. Okay, last problem. See, there's still like remnants of statics questions. A ball is thrown upward at an angle of 30 degrees. Okay, 30 degrees thrown upward to the horizontal and lands on the top of the edge of the building 20 meters away, 5 meters above the throwing point. How fast was the ball thrown? Oh, this is like Sakuragi, but Sakuragi, you are asked to get the time of flight for Sakuragi, you know. We have time. We could solve this via component. For you guys at home or or guys watching, you could use extano, just like what we did for Sakuragi. Alright? But for me, this one is theta. Okay? But for me, I'm gonna do the component method. Okay? We're gonna separate first V into two components, Vx and Vy, which is V cosine 30 and V sine 30. Okay? It is said that the distance of 20 meters was reached by the ball, right? Yeah, ball thrown at 30 degrees. 20 meters, S is equal to Vxt, right? 20 meters is equal to V cosine 30 times time of flight. Right? And sine, the 5 meters from the projectile motion, so we can do S is equal to V1t plus 1/2 G H, GT squared. GT squared to, 5 meters above is equal to V sine 30 T. Okay. Minus 1/2 times 9.81 times T squared. Okay. If we simplify this into VTF over VTF is equal to 20 over cosine 30, we could substitute it here. 5 is equal to, right, 20 sine 30 over cosine 30 minus 4.905 T squared. Okay. Put the negative on the opposite side. Put the 5 here. Alright. T squared is equal to 20 tangent 30 minus 5 divided by 4.905. Square root both sides to get the time. What will be the time? Okay. Am I solving these problems a little too fast? You know, tell me if I'm solving this problem a little too fast. Okay. I'm assuming my viewers are, they know how to transpose to move one value to another side. I'm assuming. And they're like super expert, super smart, and they don't need to watch my videos. But I hope you watch my videos, 1.9206 seconds. Okay, that is not what it asks. The velocity is the one being asked, right? So we just substitute it here. Velocity is equal to 20 cosine 30 divided by 1.9206. And whoever's my viewer is, I'm just happy that you guys are watching, and I'm always hoping that you guys are learning something and definitely not being too disgusted with my handwriting. Very beautiful. Very beautiful indeed. Oh, disgusting. Anyways. 12.02. Wait, is that the real answer? 20 divided by cosine 30 divided by 1.9006. V is equal to 12.0244. 12.0244 meters per second. Okay, double check. 5 meters above V sine 30, 20 cosine 30 below VTF, minus 4.905. I think that's correct. Let me just do this again. Okay, 20 tangent 30 minus 5 divided by 4.90. Oh, we got it all wrong. 1.15532. Okay, always double check your answer. Even I do things wrong most of the time. Even I do things wrong most of the time. The difference probably me and my college me is I don't trust myself. So that's why I always recheck what I'm doing. Trusting yourself is comfort. What am I saying? Well, I think trusting yourself is a good thing, but sometimes cautioning what you're doing is also a good thing. 19.8 9896. I'm not saying doubt yourself. I'm not doubting myself. I can solve this problem. But sometimes I double check the answer. I double check what's my answer and my solution, because it's what good engineers do. It's what good engineers do. And it's the trust that I double check my answer. 19.9896 or 20 meters per second. That's the answer. I hope you guys have learned something from this kinematics video. Guys, see you guys for more. We're gonna do work, power, energy. See you guys for more. Bye bye. Thank you so much for watching. Bye bye.